to do a table like this. Okay, what's your questions on this table? So first off, you know this is based on this table right here. Kari, Thomas, y'all are in completely different groups. Don't talk to each other. Work on your math right now. Gentlemen in group 6, you're talking to one of them, glad you get involved, but Ethan, get involved with them. I see the two of them working. Get involved on your learning. You're just sitting back, not doing anything right now. It's not. Don't look at me like that. I watched you for long enough to know that you were not just stretching. So, notice how we named this the temperature, so that's what this is, the dependent variable. We named this the customers, so that's the dependent variable here. We just put in the number, that's it. Get with that? If I ask you to get the least squares regression going, what you're going to want to do is make a table like that. Now you need to get that data and statistics graph. You remember how you created a page on the calculator? Okay, so right here in gray versus plus page. Now you need to get on the control. That's what that C is. Control. Just hit it once. Nope. No, sir. I'm Italian. The plus page is literally says plus page, right? Brooklyn. Groups here. Plus page. Just hit it. Plus page. There you go. The page you need is the data statistics. And so, remember the x-axis is your independent variable. Which is your independent or x variable here? Remember, it's always x and then y. So which one's your x? Your independent variable. So right there it says to add a variable. Uh-oh. And then what's the deep under? Okay. So there's your scatter plot. I'll come back to you in a second and finish this. Okay? Huh? So, first things first, what's my slope? Slope can never be x. We can find the slope with the x. Slope is equal to, and note I'm writing it up here to have more room, but this is number 5, 0.687. But how do we calculate slope? That's the equation of the line. I said slope. So change in y divided by the change in x. Okay, so what's the division by here? It's always understood to be divided by 1, right? Now you can interpret that slope if that's one of the things that you were struggling with. Do not forget which variable was y in the context of the problem. No. Listen to my question. What was the variable y in the context of the problem?
0.
Hey, Brooklyn and Marlon, I need your eyes up here on the board. Up here on the board. With pencil in hand, ready to take notes. Brooklyn, you're still not, haven't even looked at the board yet. Okay. Look at the table again. What variable was the y, the dependent variable? The number of customers. Thank you.
Good job.
And so what was the x? We're looking at a new problem, temperature, right?
Good job.
There we go. So there's my x and there's my y. So now I need to put this into context, just like you did before. It's as the x either increases or decreases. So I want you to talk about that in your small groups in just a second. But I'm going to leave this there for you to finish interpreting. But I will also point out what was the y-intercept.
41.2.
Okay, but y-intercept is a point. So what is the 0, comma? 41.2. And don't forget this 0, is that X or is that Y? That's X. 41.2 is? And so again, still number of customers and temperature. But pay attention. This is as the variables change. Are the variables changing here?
No.
No. So, hey, Jordan, I'm teaching, man. Like, if it didn't matter, I don't know, an hour, 15 minutes ago, it doesn't matter now. So, work within your small groups to finish interpreting. We'll go over this in just a minute.
Okay. So you remember how we did it?
Yeah. So what's the one button that allows you to do almost everything in this calculator? Okay? To analyze the graph. Least squares see anything there that would go with a least squares regression. All of these are regressions. You want a least squares regression show linear. Here it is. Now you have to just you're done. That's exactly what that one said, right? Isn't that the equation you have written down right here? It's just rounded differently. It's the same. Okay? And now we're interpreting. All right. So how would we talk about this slope? Are we going to start with our y or with the x? You always start with the independent. Remember, we also call that the explanatory variable. So as what? As the
temperature increases by 1.
there we go. So as the temperature increases. Okay, so let's pause, and that's a great question. This 1 was not originally there, was it? But remember, I want the change in y divided by the change in x. So I need a y and I need an x. And you were asking that, right? But what can everything be understood to be divided by? 1. Everything is always understood to be divided by 1, right? So now if you think about it this way, what is 3 divided by 1? 3. What is 17 divided by 1? So everything could be understood to be divided by 1. So we put it there so that we have a change in y and a change in x. Yes, Maddie? Okay, so as the temperature increases by 1, what about the customers? You're missing one detail.
The number.
The number of customers typically increase. You said by 41.2? Does everyone agree with that? By 41.2? Look again.
Yeah.
Look again. Jordan, you haven't even looked at the board, my man.
I did.
No, you didn't. Remember, this is my slope, isn't it? The 41.2 is my y-intercept. So you got to be careful. Remember, that's the 1. We got the 0.687 with it. So how much do the number of customers typically increase? 0.687. Excellent job, Maddie, on that language, but you got to be careful that we're focusing on the slope. Okay, so I'm glad you made that mistake so we can talk about it. You got to keep your slope and your y-intercept separate. Okay? What are your questions at this point? So we still need to talk about the what?
That one?
What's that one?
The X. No, the Y-intercept.
Remember, that's the slope-intercept, the y-intercept. And so, are we still talking about increasing and decreasing over here? Notice, does it say change in x? It doesn't, so it's not the change. It's not increase, it's not decrease. It just is. So 0 what? 0 is the x, but what is x? It is the temperature is the x, right? So 0 what?
Degrees.
Degrees Fahrenheit. So you notice when you pay attention over to our table, the temperature is in degrees Fahrenheit, because that's different than degrees Celsius, right?
Yeah.
So when the temperature is 0 degrees Fahrenheit, then what?
And the number of customers increases.
So be careful. You're on a good idea, because we do have the number of customers as our Y, but is that a change in Y?
No.
So it's not about increase and decrease. The number of customers is what?
41.2.
Can the number of customers be 41.2?
No,
It has to
just
be 41 exact.
So say that one more time, Clark. We got to remember that this is all based on the least squares regression line, a prediction. So if we include that detail, the predicted number of customers is what? Right. Okay? And so just that one detail changes things, because a prediction is a lot like an average. Does an average have to be an exact value that's possible? No, it doesn't. It's just an average. And so the predicted number of customers is 41.2. All right? Right, because notice, like, what does that Greek letter delta mean? Change, right? And so this is how much it's changing by. Because it's positive, it's increasing. If it was negative, it would be decreasing. But remember, change in Y and change in X is only a slope idea. This isn't a slope, this is just a single point. Notice there's no change in Y, or change in X and change in Y, it's just X and Y. Okay? And so because it's not a change, we're not talking about increasing and decreasing. And so that's a really important part. And I think, Joey, you were talking about the increase in number of customers, right? And that's a great mistake that a lot of people make. And I'm glad you made that so we can talk about it. We need to be careful that a Y-intercept is not a change. A Y-intercept is a point. That's it. There's no changing here. Only the slope has changed. The change in Y and the change in X. What are your questions before we continue? Okay. So, I don't know why part of it didn't show up. There it is. This is what we did originally, right? Numbers 1 and 2, we've already done. You don't need to worry about that. Numbers 1 and 2, we had a trend line that we thought represented the data. We had predicted number of customers based on the temperature. We're going to redo this with number 5 now that we have this equation, right? We have y hat equals 0.687x plus 41.2. It says now use the new line of best fits to predict the number of customers. Hey, eyes up here. No, you're looking over there. My bad, Thomas. So, predict the number of customers. So, how can we go about using that 85 degrees Fahrenheit to predict how many customers there are? Substitute it in for, how do we know it's in for X and not for Y?
Because the Y is already given.
The Y, well, so actually the Y is not given right now. Look right here. How do I know that this is going to be substituted in for X? Because it's temperature, and which variable is temperature? X, right? Temp is equal to X, so substitute for X. Do you think I care if you use a calculator on something like this?
No.
Heck no. Are you going to be able to use a calculator on the test for this? Heck yes. So use your calculator. Show me your work, right? If you make a mistake in the calculator, I can't see it. What could you show me here for A to show me you knew what to do?
Write down some information.
Write down the equation. We already have the equation. So what am I going to do with this equation and this number?
Substitute 85.
Okay, so I've got y hat equals
85.
0.687, 85. Oh, in parentheses.
I was saying, it needs to be multiplied, so you can use parentheses or the dot. So times 85.
Plus 41.2.
Can you put it into the calculator from there? Yes. So show me it substituted in, put it into the calculator. Let's get these answers knocked out. No. This is for, guys, this isn't for number 2. We're looking at number 6. We're looking at 5 and 6 right now. Yeah, round it a little bit.
So 99.
Joey, have you done these calculations in your calculator yet? You don't know how to do what? You don't do that in the calculator, but you just type in the right-hand side that you're trying to simplify. The 0.687 times 85 plus 41.2. So you can just create a new page, but that's not just well. You say that, it'll keep it there. Oh. There it is. You didn't lose it, you just escape after you do the calculations. Okay, let's continue. Guys, after you get A, get B. After you finish A, move on to B and C. You already did all 3? Okay? So go ahead. Well then, Maddie, tell me what you got for A. I assume you were the one who said y'all were done?
I got 99.6.
99 point what? You rounded it? 99.6 what? Degrees Fahrenheit. Okay, B? 120 point what? 2 degrees Fahrenheit. And C? I mean, you can round it. I'm fine with anything closer. Okay, does anybody want to push back on any of these answers? Yes?
I didn't use the logic this. I don't know if I did something wrong.
You didn't get those numbers?
I got off just by.
You did 867. Is that 687?
Oh.
Yep. I will say there's one major mistake up here. Does anyone know what it is?
What is a mistake?
I didn't say any of the numbers were wrong. Hey guys, the input was degrees Fahrenheit. The X was the temperature. What was I calculating?
Temperature?
I had the temperature. I was saying, I'm trying to find Y, right? Y was not the temperature, it was the number of
Customers.
So if it was 85 degrees outside, we predicted to see how many customers? 99.6 customers. The degrees Fahrenheit is predicting the number of customers. If it was 115 outside,
120 customers.
120.2 customers. Now, will you have exactly that many?
No, it's the prediction.
It's just the predicted. We need to be careful to remember that. 48, so Y hat is equal to 48.1 customers.
So that was on all of them?
That is all 3 of them. Okay. So how do our predictions compare? Pretty close? Yep. Which ones do you think are more accurate probably? The second set, right? The second set are definitely more accurate because we used which prediction line? Which prediction line?
Least predicted.
Least squares Regression line, right? Remember when we use that least squares regression line, we're using the best trend line. It's also called a line of best fit. A line of best fit is the best trend line is the least squares regression line. Okay, so this is what we did. We're not going to stress about this. This is the book just explaining the least squares regression line, but we've already done this. Hey, Ezra, you should calm down, buddy. Okay, we've already done the least squares regression line, and we did it on the calculator. Okay, so I do want to address these ideas. What do the vertical lines in bold represent? So that's these lines. Say it louder. Residuals, right? Those bold vertical lines are our residuals, right? It's only like the 4th day or 5th day we talked about it in class. Come on, Jordan. You're super intelligent, man.
Which page this is? Which page this is?
171.
Oh, sorry, yeah, it's page 171 in the book. Okay? So I'm not going to stress about B, but I do want to emphasize that idea that the vertical lines are the residuals. Hey, Ezra, did you ever give me your folder? Did you ever give me your folder? Jordan. Did you pick up all your stuff and get ready for it? Okay. So, back to the next right there. So, hey guys, activity 1.2 is what we are picking up right now. In order to do all of this, we'll probably need to go into tomorrow, but what is the range of the data set? The table shows the lists the average global temperatures in 5-year spans from 1956 to 2016. How could I figure out the range of that data set? It sounds like we forgot last unit already. How do I calculate a range?
Max minus min.
Thank you. All right, range. Max minus min. Does anyone see the maximum value in there?
12.
Wait a second. Is that's the span of years? What is this all about?
58,458.
Yeah. 58.448 minus
57.250.
I would check again. I think there's one value or a couple values actually below 57.25. I think that's the minimum. And I'm actually checking to see. No, that is the max. Okay, so minus 57.121. You got to pay attention to what the min and max in the data set are. Well, we're not even necessarily doing that. By the way, it's page 173 if you're looking for it. Okay, M1-173. I'm just looking for the max and the min. I'm not looking for the 5-number summary, just the max and min. And so if I subtract that, I get 1.327 degrees Fahrenheit. I think that's right. Can someone put in the calculator?
Yeah, that's right.
What's up, 9? Okay. Alright. So, identifying the independent and dependent quantities. We're going to go from here. what's the independent quantities? That's the years, right? Now, to make our job easier, because we're looking at 5-year spans, we're going to talk about every span. So, because we're looking at sets of 5 years, right here, Joey, we're going to use the span, so the number of spans that we have, right? So, that's the first span of 5 years, the second span of 5 years. So, the independent...
Good afternoon, Papa.
Hey, don't pack until you have this written down.
We'll be back tomorrow. Collect order forms for senior supply. If you need a back packet, please put one up in your circle.
Yeah, so the independent variables, the spans of 5 years, the dependent is the average
Also, follow us on Instagram for more important updates.
in degrees Fahrenheit. Right?
There'll be a
That's it for that question. That's what we'll pick up tomorrow. We'll work through that as much as possible.
Or you can eat it and
Say again. So like, how far apart? So it's a span of 5 years. So the first span, how are we going to get that for 5 years? So that's what we're talking about. Span of 5 years. Yes. You don't have to stress it out again. That's not interesting. I'll be quick. Look. That's not you. Oh, that's 10th grade. You're good. Yeah. Oh, that's not you? Okay. Hey, but beyond that, I need you to stay awake, my guy. It's real hard to learn being asleep. Hey, Jerry! Tim boy's out cold. He always is. I know.
Seems like that always happens.
Yeah.